Hello, everyone. Welcome to the Chemical Safety Technology course. I am your instructor, Suo Yanbo. In this session, we will explore the definitions and classifications of hazardous chemicals. Suo Yanbo is a senior engineer, registered safety engineer, associate professor, senior technician in chemical process control and chemical testing, and an assessor for chemical process control technicians. Since beginning his teaching career, I has taught courses such as Chemical Safety Technology, Chemical Unit Operations and Equipment, and Chemical Equipment. I have published numerous papers and hold one authorized patent. I have received honors including Top 10 Chief Technicians of Binzhou City, Bohai Craftsman, Bohai Talent Card, Shandong Huisai Card, Technical Expert of Shandong's Chemical Industry, Outstanding Young Professional of Shandong Province, Work Safety Expert of Shandong's Chlor-Alkali Industry, Qilu Chief Technician, National Outstanding Young Professional, and Expert in the China Chemical Safety Association's Expert Database. Before studying the definition and classification of hazardous chemicals, let's first review the August 12, 2015, Tianjin Binhai New Area Explosion. Please watch the video.
At about 23:34 on the 12th of August, 2015, a catastrophic fire and explosion broke out at the hazardous chemicals warehouse of Ruhai International Logistics Company, Limited, hereinafter referred to as Ruhai Company in Tianjin Port, Binhai New Area, Tianjin. The incident resulted in 165 fatalities, 8 missing persons and 798 hospitalized casualties, causing direct economic losses of 6,866,000,000 renminbi yuan. Investigation findings confirmed that the 12th of August accident at Ruhai's dangerous goods warehouse in Tianjin Port constituted an extraordinarily severe work safety liability accident.
We saw that the explosion originated in the hazardous materials warehouse of Ruhai Company in the Binhai New Area. Which hazardous chemicals were involved in this accident? According to the accident investigation report, prior to the incident, the Ruhai Company hazardous materials warehoused a total of 111 types of hazardous goods across 7 major categories, amounting to over 11,000 tons. Of these, 72 types totaling 4,840.42 tons were stored in the receiving area, including 800 tons of ammonium nitrate, 360 tons of sodium cyanide, and 48.17 tons of nitrocellulose solution and nitrocellulose paint chips. The investigation report ultimately determined that the cause of the accident was nitrocellulose, a hazardous chemical stored in a container on the south side of the Ruhai Company's hazardous materials warehouse receiving area. Due to the loss of wetting agents, localized drying occurred. Under the influence of high temperatures and other factors, this accelerated decomposition and heat release, leading to heat accumulation and spontaneous combustion. This triggered a prolonged, widespread fire involving nitrocellulose and other hazardous chemicals in adjacent containers, which in turn caused the explosion of hazardous chemicals such as ammonium nitrate stored in the arrival area. So, what exactly are hazardous chemicals? Article 3 of the Regulations on the Safety Management of Hazardous Chemicals stipulates that hazardous chemicals refer to highly toxic chemicals and other chemicals that possess properties such as toxicity, corrosiveness, explosiveness, flammability or oxidizing properties, and pose a hazard to human health, facilities, and the environment. According to the National Standard for the Classification and Identification of Dangerous Goods, hazardous chemicals are divided into 9 categories. Category 1, Explosives. This category is subdivided into 6 subcategories. For explosives, explosiveness is the primary characteristic of all items in this category. Explosives are highly sensitive to impact, friction, and temperature, and some also possess a certain degree of toxicity. Generally, explosives can react with acids, alkalis, salts, and metals such as fireworks, firecrackers, detonators, and explosives. Class 2, gases, including compressed gases, liquefied gases, dissolved gases, and cryogenic liquefied gases. When subjected to heat, impact, or intense vibration, the pressure inside the container increases rapidly, which can cause the container to rupture, resulting in a physical explosion, or lead to a substance leak, resulting in a chemical explosion. This class is divided into 3 subclasses. Subclass 2.1 Flammable gases. Examples include ammonia, carbon monoxide, and methane. Class 2.2 Non-flammable, non-toxic gases, including asphyxiant and oxidizing gases, such as nitrogen and oxygen. Class 2.3 Toxic gases, such as chlorine, ammonia, and hydrogen sulfide. Class 3 Flammable liquids. This class includes flammable liquids and liquid desensitized explosives. Flammable liquids primarily refer to liquids with a closed cup flash point of 60 degrees Celsius or less, or an open cup flash point of 65.6 degrees Celsius or less, such as gasoline, acetaldehyde, acetone, benzene, methanol, and chlorobenzene. Liquid desensitized explosives refer to explosive substances dissolved or suspended in water or other liquid substances to form a homogeneous liquid mixture, thereby suppressing their explosive properties. This involves the concept of flash point, also known as the flash ignition point, which is the temperature at which a mixture of vapor and air on the surface of a flammable liquid first produces a blue flame upon contact with a flame. We have listed the flash points of common flammable and combustible liquids. As shown in the table, the flash points of gasoline, crude oil, methanol, and ethanol are all very low. The lower the flash point, the easier it is to ignite. Class 4 is divided into 3 subcategories. Subcategory 4.1 includes flammable solids, self-reactive substances, and desensitized explosives in solid form, such as the celluloid used in table tennis balls found in matches. Subcategory 4.2 includes substances liable to spontaneous combustion, such as white phosphorus and sodium sulfide. Subcategory 4.3 includes substances that emit flammable gases when in contact with water, such as metallic sodium and calcium carbide. Class 5 Oxidizing substances and organic peroxides. Substances in this class are highly oxidizing and can easily cause combustion or explosion. It is divided into 2 subclasses. 5.1 Oxidizing agents such as bleaching powder, hydrogen peroxide, chemical oxygen generators, and potassium permanganate. And 5.2 Organic peroxides such as peracetic acid used as a sterilant. Class 6 Toxic and infectious substances. This class is divided into 2 subclasses. Subclass 6.1 Toxic substances refers to substances that, if ingested, inhaled, or in contact with the skin, may cause death, serious injury, or harm to human health, such as potassium cyanide and arsenic. Trioxide arsenic. Class 6.2 Infectious substances are substances known or reasonably believed to contain pathogens such as bacteria, viruses, parasites, fungi, etc. Class 7 Radioactive materials. The atomic nuclei of these materials undergo decay, emitting radiation that is invisible to the naked eye and imperceptible to the senses. It can only be detected using specialized instruments. Radioactive materials are generally metals with very high atomic masses, such as uranium and plutonium. The radiation emitted by radioactive materials can be classified into 4 types: alpha rays, also known as type A rays; beta rays, also known as type B rays; gamma rays, also known as type C rays; and neutron flux. Class 8 Corrosive substances. Corrosive substances are those that, through chemical action, cause severe damage to biological tissues upon contact, or that, if leaked, can severely damage or even destroy other cargo or transport vehicles. Common corrosive substances include acidic corrosives such as sulfuric acid, nitric acid, and hydrochloric acid; alkaline corrosives such as sodium hydroxide and calcium hydrosulfide. Other corrosives include dichloroacetaldehyde and sodium phenolate. Class 9 Miscellaneous dangerous substances and articles. This category includes substances and articles that pose a hazard but do not meet the definitions of other classes, such as lithium battery packs, life-saving equipment, and articles that release toxic substances upon ignition. It also includes fine dust and other particles that are hazardous to health if inhaled. In this lesson, we learned about the definition and classification of hazardous chemicals, understood how the regulations on the safety management of hazardous chemicals define hazardous chemicals, and learned that hazardous chemicals are divided into 9 categories. That concludes this lesson. For your homework, please consider the following question. Into how many categories are hazardous chemicals classified based on their hazardous properties? Alright, that concludes this session. See you in the next class.